this video, we're going to take a look at the procedure known as Gauss-Jordan elimination. This elimination procedure uses elementary row operations to change a matrix to reduced row echelon form. Okay, this is a little bit different from Gaussian elimination, but it follows mostly the same general procedure. To create our leading ones, we're still going to use a type 1 elementary row operation. We're going to multiply by a non-zero number. The only difference now is when we go to create our zeros, we have to create them both above and below our leading ones. That's really the main difference between Gauss-Jordan and Gaussian eliminations. So let's go ahead and work through those two examples one more time, only in this instance we're going to try to get to reduced row echelon form. Hopefully this will show you the difference between the two methods. So just like we did before, we're going to take row 1 and we are going to divide by 2. And that's because we'd like to create our first leading one here in the upper left corner. When we perform this elementary row operation, we end up with a new matrix, 1, minus 3, minus 2. And row 2 and row 3 will remain the same. So 0, 1, 3, 0, 0, 1 half. Alright, after we create this first leading one, what we're usually going to do is see if we need to create zeros below that leading one. In this case, we already have zeros, so we're good to go. Our column 1 is complete. So how I think about it is I now cover up column 1 and I focus on column 2. Is column 2 the way that I need it to look in order for my matrix to be in reduced row echelon form? Well, I have my leading one in row 2, so that's a good start. But we don't have zeros in this entire column. So our next goal is to try to get this minus 3 to a 0. So we have to use a type 2 elementary row operation on row 1. We are going to change row 1, and we're going to add 3 row 2s. So at the bottom, I'll go ahead and I will show you what this operation is going to look like. And let's go ahead and write down the new matrix that we're going to get after we do this operation. So we're going to get 1 plus 3 times 0, so that's going to be 1 plus 0. Next up, we'll have minus 3 plus 3. That'll give us 0. And finally, we will have negative 2 plus 9, or 9 minus 2. That's going to give us 7. And once more, row 2 and row 3 are not going to change, so we can just copy them back down. So now we have a completed second column. We have our leading one, we have our zeros above and below our leading one. So column 1 and column 2 are completed. So the last thing we're going to look to do is transform column 3 into reduced row echelon form. And we begin by creating our leading one down here in the bottom right. And we do that just like we did before by taking row 3 and multiplying by 2. So I've gone ahead and I've multiplied row 3 by 2. And now we have to focus on the entries that are above our last leading one. So take a moment to pause the video and see if you can come up with 2 elementary row operations that are going to create zeros here where the 7 is, and a 0 here where the 3 is. Okay, first I'm going to do row 1 minus 7 row 3s. Okay, I choose row 1 because that's the row that I would like to change. I would like to change this 7 into a 0. I have a minus 7 here, that's the opposite sign of this 7 here. And then row 3 is the row that contains the leading one that I'm going to use to make the change. So I'm going to show you at the bottom that operation. So let's go ahead and compute it. So up top we'll have 1 minus 0, 0 minus 0, 7 minus 7. So here's our new row 1. Our row 2 and our row 3 remain unchanged. And our last operation we're going to do is row 2 minus 3, row 3. So once more we'll have row 2 because we'd like to change the 3 to a 0. Negative 3 here, that's the opposite of our positive 3. Row 3 is the row that contains the leading one. Okay, once more I'll show you those computations at the bottom. And that's going to give us a final matrix 1, 0, 0, 0, 1, 0, 0, 0, and 1. And you can check that this final matrix here is indeed in reduced row echelon form. Alright, so let's work through another example here. Okay, once again I want you to start working column by column. So we're going to look at column 1, and we're going to try to create a leading one as high as we can possibly create our leading one. And that's going to be in the uppermost left position right here. So in order for us to create a leading one here, we could take that fraction and multiply it by 4. And that's what we're going to do to this entire row. So we're going to change row 1 by multiplying it by 4. Alright, we've done this operation already in the last video. That's going to give us 1, 3, minus 4 for row 1. And there is no change to row 2, so we're just going to go ahead and rewrite row 2 once more. Alright, so now we have our leading one in the correct spot. We need to make this negative 1 into a 0. So we're going to have to use a type 2 operation here. We need to change row 2, so that's going to come first. We're going to take this value and switch the sign. So plus 1, and then the row containing the leading one is up here, and that's row 1. So that's how we write our type 2 operations. So let's go ahead and write this one down. Row 1 does not change. We're left with 1, 3, minus 4. And it's row 2 that's going to change here. We're going to have minus 1 plus 1 for 0. Minus 1 plus 3, that's the same as 3 subtract 1. So we're going to have 2 here. And we're going to have 2 minus 4, negative 4 plus 2 for negative 2. If you need to see those computations again, I'll leave them over on the side for you. Okay, so you can check now that this completes column number 1. So we think about covering up column 1, we'll move over to the next column. And the next candidate for our leading one would be right here. Remember, our leading ones have to be below and to the right of a leading one above it. So I'm interested in changing this into a 1, and I can do this by dividing the entire row by 2. So I write this as 1/2 row 2. Alright, we are almost there. We finished up column 1, we have our leading one, we have zeros underneath our leading one. We're just going to finish up column 2. We have our leading one here. We just have to create a 0 above our leading one, and then we should be good to go. So we're going to change row 1. We're going to subtract 3. That's the opposite of the number we're trying to change into 0. And it's row 2 that has our leading one in it. So row 1 minus 3 row 2s. I'm going to show that operation to you below here. Alright, and let's go ahead and write that one down. So we have 1 minus 0 for 1, 3 minus 3 for 0, minus 4 plus 3 for negative 1. Row 2 has no change, so here is row 2, and our final matrix looks like this. And you can check that this matrix does indeed satisfy all of the conditions for reduced row echelon form. And before we close off this video, I just want to note one thing, and it's probably the most important thing about reduced row echelon form. And that is that reduced row echelon form is unique. That means that if you and I start with the same matrix, and even if we do different elementary row operations, our final answer is always going to be equal. And that's a pretty important property to have. So as we're working through questions that involve elementary row operations in the future, 95% of the time we're going to use Gauss-Jordan elimination. And that's so that we can guarantee that we get a unique reduced row echelon form. Alright, my little epsilons, stay positive.